Hi, this video is going to be about balancing redox equations in basic solutions. All right, the steps for doing this are the same as the steps for balancing acidic solutions. If you notice that there are, the steps for this are on page 3 of the packet that I gave you. It's all the same steps, except at the very end, you need to get rid of the H pluses by adding OHs to both sides. So I've summarized that here. You can see all the steps for doing a basic reaction are the same as acidic, but there's just an extra step at the bottom. All right, we're going to be doing this by working in the packet that we've done before. So this is the worksheet 5 packet. And we're going to, in particular, look at number 13. We're going to do number 13 as an example here. All right, so I've rewritten number 13 on this paper to help us do this a little bit easier. I'm also going to be following the steps as we go through. So steps to balance a redox equation are right here. All right, I'm going to point out that, again, the reason that we need to do this is because when we balance equations, unlike Chem 1, we need to also make sure that charges are balanced. And charges are definitely not balanced in number 13. If you notice, there's a 3 plus here and a 2 minus there. The charges aren't balanced. We need to make sure that everything is working the way that it should, that when you have oxidation and reduction, that you have the correct number of electrons going back and forth between the two species. And that's all behind the scenes. All right, this one's in basic solution, so we're going to go through all the same steps as in the acidic solution, and at the very end, we're going to change something. All right, we're going to start with step number 1, or actually 0 here. Determine the oxidation states of everything. So if we go through, oxygen's an element alone, so it's going to have an oxidation state of 0. Chromium, oxidation state is the same as charge. H2O2, this is a peroxide, and if we remember in peroxides, the oxygens are bonded to each other, and so they can't steal electrons from each other. They're only going to take the electron from the hydrogen. Hydrogen is going to be 1 plus. And finally, over here, this is chromium, or actually the dichromate ion. And in the dichromate ion, oxygen is more electronegative, so it takes 2 electrons. So it's going to be 2 minus charge right there. And there are 7 of them, so it's 14 minuses. But all the chromium and all the oxygen have to add up to 2 minus. So that means the chromium part has to be 12 positives. And the 12 pluses have to be split up among the 2 chromiums. So each chromium is 6 plus. All right, I just finished the first step, which is to determine the oxidation state. What you'll notice here is that chromium is turning from 3 plus to 6 plus. So chromium is being oxidized. All right, and oxygen is actually what's being reduced here. So oxygen is gaining electrons. So you have the oxygen is gaining electrons to form the peroxide. Okay, sorry, I just had to pause the video there for a second. So for oxygen, we're going to go from a 0 oxidation state to a -1 oxidation state. Just want to point out why we're not going to care about this oxygen at the moment. We're going to be adding waters to these equations, and this oxygen is probably just from water, and water, the oxidation state of oxygen is 2 minus. So we don't have to worry about this oxygen. We're just going to worry about this one. This is the weird oxygen here. All right, so oxygen is reduced. Literally, its oxidation state goes down from 0 to -1. All right, now we're going to write our half reactions. When we write our half reactions, we're going to be going and writing an equation for the oxidation and the equation for the reduction. So we're just going to pay attention to the species that is oxidized in the oxidation one. So the half reaction for oxidation is Cr3 plus makes Cr2O72 minus. We have to write the entire chromium dichromate ion here because the chromium is bonded to oxygen, so we got to bring the oxygen along in the half reaction. Okay, so that's the oxidation half reaction. Now we need to do the reduction half reaction. So we're going to write O2, and we're going to have it go and make H2O2. All right, this time you'll notice I didn't actually bring along all the oxidation states. We're going to see what happens when we do that. All right, Now we need to balance the half reactions. We're going to do this by first balancing atoms that aren't oxygen and hydrogen. Then we're going to balance the oxygen and the hydrogen. So if you look here, there's 2 chromiums on this side and 1 on this side. So we're going to write 2 here. And if you look down here, O2 and O2, so we're good. In fact, there's no atoms other than hydrogen and oxygen here, so no big problem. Okay, we've got to move on to balancing oxygen by adding plus H2O. So there's 7 oxygens on this side. We've got to write 7 waters on this side because that's where we're going to balance the oxygen. Down here, oxygen's balanced, all set. Now let's go to balance the hydrogens. We're going to balance the hydrogens by adding H+. Right, you'll notice there are now 14 hydrogens here. We're going to have 14 hydrogens on this side to balance it. So we're going to write 14 H pluses here. We've got 2 hydrogens here. We're going to have balance it with 2 hydrogens on this side. All right, we have now balanced our half reactions by atoms. Now we've got to balance the charges. And we're going to add electrons to do that. Okay, so you notice I didn't write the oxidation states this time. It's going to be a lot easier to make sure my charges are all set here. All right, what we'll notice is that there's 3 plus here, but there's 2 of them. So that means on this entire side of the reaction, there are 6 positives. On this side of the reaction, there's a 2 minus, and then there are 14 positives. So that overall is 12 positive. So you can see there's a problem. You can't get 6 positive to be 12 positive. So what we're going to do is, I'm going to move that, ox and reduction. We're going to need to have 6 extra negatives here on the more positive side to balance out the 6 positive. So I'm going to write plus 6 electrons. That means now it's not 12 positive, it's 6 positive. Okay, in the reduction half reaction, we can see that there's 2 positives here and it's 0 on this side. So on the more positive side, we have to add the 2 electrons. Now it's not 2 positive, it's 0. So we've just balanced charges, 6 plus to 6 plus, 0 to 0, no problems. Okay, now we need to, we're in a second going to add up these 2 half reactions to get our final equation. But when we add them up, we need to make sure there's no electrons left over. And so we have 2 electrons here and we have 6 electrons here. So what we'll notice is that we have to make sure that this is going to be 6 electrons also. This entire equation, in other words, has to be multiplied by 3. Okay, that's going to make this 6 electrons. That's going to make this 6 hydrogens. You're going to have 3 O2s there. And you're going to have 3 H2O2s. And so I just multiply them so I can cross that out. All right. So now, when I go and add these up, because that's what I'm going to do in step 5, I'm going to sum them up. I'm going to be able to cancel the electrons and anything else that appears on both sides. So 6 electrons are here and 6 electrons are here. We can't have leftover electrons. Okay, we got 6 hydrogens here and 14 here. That will partially cancel. So 6 hydrogens will cancel 14 and leave behind 8. We have 7 waters here, and we don't have any waters on this side, so no problem. I think that's it. So now I'm going to go add everything up. So I've got 7 H2Os, plus I've got 2 Cr3 pluses, plus I've got the 3 O2s, and I want that to make the 3 H2Os, oh, sorry, shouldn't be a 2 there, plus the Cr2O7, 2 minus, plus the 8 H pluses. All right, that's the answer if this was in an acidic environment. So you'll notice that H pluses can only pretty much exist in an acid. But if you're in a basic environment like this number 13, it said it was in a basic solution, then what we've got to do is we've got to make sure there's no H pluses in the final reaction. And the way we're going to do that is we're going to add plus H plus to both sides of the reaction for every H plus. That'll cancel as water. So if you notice here, there are 8 H pluses. That means we need to write 8 plus 8 OHs to both sides. All right. Here's what that's going to do. 8 H pluses and 8 OHs. As soon as the H pluses are formed in basic solution, they react away with OHs and they form 8 waters. But you'll notice there's 7 waters over here. 7 waters make 8 waters. So that actually cancels now and leaves behind 1 water. And that's going to be the final answer. So I'm going to rewrite it. 2Cr3 plus the 3 O2s plus now there's 8 hydroxides. This happened in a basic solution, so there should be extra hydroxides around. Make, oh, I forgot about the waters over here. Oh, I got to add it to the 1. So 1 plus 3 is 4 waters plus the dichromate ion. And that's it. I think that's it. Oh, wait. Ooh. No, I messed up here. That's 3. That's supposed to be a 2. That's not a water. I shouldn't have crossed out that 2. And so that doesn't mean that that's 4 waters. That's actually supposed to be 3 H2O2s plus the 1 water. Okay, by the way, I just caught myself there. The reason I just caught myself is because I realized that dichromate ion and water, the chromate was the thing that was oxidized, but I didn't have anything that was reduced because water has the same oxidation states as hydroxide. It's just acid-base. So that's how I caught myself like, oh, there's not enough things over here. There should be 2 species besides the water. All right, so I did that because I was a little sloppy. And that's going to sum up something that you need to know about the balancing these reactions. You got to pay really, really close attention to detail. If you don't pay close attention to detail, things can get away from you really quick, and you can mess up on the answer.